Yeah, welcome back to the part two of the road traffic intersection tutorial using Anylogic. In the first part of the video, we were able to set up the phase one and the phase two of the road layout. So that is the first thing we had to do was when we opened the software, we were able to introduce the image layout into the interface. Then afterwards, we're also able to draw the road leading from the south to the north. And after when we did that, we adjusted and we modified the properties, and we also introduced the car type into the model. Then we also created the east road, and we so far we have been able to have the forward lane and also the backward lane movement in this layout. So the next thing, so here is the flow chart. That is the castles, the movement from the south. The S here represents the south to the north. Then car disposed out of the model, and we also have the movement from the north. That is the backward lane from the north back to the south. Then the car disposed. So far we've been able to work on the movement from the south to the north and also from the north to the south. Now the only thing we want to do is the introduction of the road east. We've been able to create the road east, but it's also important for us to be able to add the flow, that is the block, into the flow chart. So this is for the north and south, south and north, but we also need to add the car source for the east into the flow chart, whereby we'll be able to have movement on the road east. And in order to do that, we also bring in the the car source for the east. So that means we are going to be introducing the car source. So after introducing the car source, so in this case, when we look at it, if we have vehicles coming having the source from the east here, so that means is either we have the movement here to the north road or to the south road. So that means there is a possibility of movement into them in two direction when we have it in this road east. So there is a possibility of movement to the north and also to the south. So that means we'll be introducing a way whereby it will connect to the north and also connect to the south. I also, in the previous video, in the part one of this video, I was able to also explain what we call the select output. It helps to link more than just one to the road. So if we want to connect, for example, where we have this car source and we said this, let's change the properties first. So we change the properties of the car source by making it the car source E, which shows that for the east, yes, and then we have the new car. We change it to T car. That is what we've been using from the part one of the video. So we have the T car. So we still have it as a ticker. Then the next thing we are going to do is to change for the road. Since what road are we? We are using the road east, so we change this to road east. So our forward lane will still remain. So every other thing remains. So we change. This is what we changed by naming it as car source E. That is, it is coming from that source. And also the road will be road east because that is the road is going through. And the new car, we are using our own invented car. That is the ticker. So after when we've done this, we can then close. So that means we'll be able to have our car source E. So we have this for the south, we have for the north, then we also have another car source coming from the east road. Like I said, this is the road east. Now, the next thing we're going to be doing here is the introduction of our select output. The select output helps us to connect this car source E to the north and also the south, like I rightly explained some minutes ago. So we need to be able to, because we cannot just connect it. If we also want to set up a car move to what end here, or can't move to S here. So it will be much more complicated. But rather than doing that, it's just better for us to introduce our select output whereby it can connect to more than one place at a time. The reason why we have the can't move to N here is because we only need it to connect to one place at a time, then it goes out of the model. But this time around, the road can source E, that is the east, needs to connect to more than one place at a time. So that means we'll have the connection to the north and also to move through, can move to the south, then it goes out of the model. And in order to do that, we go. So here we have under the process modeling library, here we have the select output. So we can drag this into the model. So let me so we've been able to drag this into the model. So then we can decide to edit this. We go under the view the properties. Under the properties, we can just have it as select NS. The reason why we have it as select NS is because it's going to be linking to the north and the south. So we have it as select NS. So here we have the probability. So the probability, if we want it as 50-50%, that is, if we have 100 vehicles or 100 cars coming from the road east, then that means 50 will go to the north, 50 will go to the south. But we can, if you want to change the probabilities here, maybe we want to have it for 70% will be going to the north and 30% will be going to the south. Then we can do that here by just changing this from 0 0.5 maybe to 0 0.7 or 0 0.6. Then we know the remaining part of the probability will go to the other part of it. So that is it for this. So, but like we said, we can just leave it as at 50%. So. So now we've been able to change this to select NS. So now we need to connect it to this. So if I decide to say we want to connect this, we can decide to connect one of those points, the connector here to move car to the north, then the connector here, move car to the, but first we have to, the connection between, there has to be a connection here. So since we've been able to connect that, we can also have a connection that leads to here. So we've been able to connect. So from the car source now it is being connected to the node, and we do the same. So we also connect it this way. So it shows that when we have the vehicles moving from the car source A, they will go through this point. So some of them will go to this north, some will be going to the north, will move through the north, and some will go through the to the south. So at the end of the day, there's still going to be a car disposed. So here we have the ones coming from the south going to the north and still exiting. The one coming from the north moving through to the south and exiting the model. And we also have that coming also from the east, connecting to both the north and the south. So if we try to run the model, we will see the how it works. So let's quickly try to do that so we can see the the interaction between the three routes, the north, south, and the east. So far now we've only been able to introduce it. We're just taking it one at a time, introducing the Casus E going through the north and the south. We'll also be able to do the same for the Casus S, because right now the Casus S is only moving through to the north and exiting, and the north is also moving to the south and exiting. So there is also a possibility whereby we'll have it leaving the north and also moving through the south, leaving the south, moving through the north and also the east, north and the east, and also for the south and for the north we connect it from to the south and the east. So let's just see how of the introduction of the blocks into the flow chart. for the road east to accommodate movement of vehicles through the north. So yeah, this direction, so we've been able to introduce it in the northeast. So vehicles going in this direction, you can see, and some of them also going in the other. So this direction, or it's going in the. So this is just a closer look at it. You can zoom in. You can see some of the vehicles going coming this way, and some of them are also going. So this is a movement from the east to the south, and also we have movement from the east to the north. So So now that we have been able to do that, we can see the movement from the east going through the both the north and the south. It's also high time for us to be able to do the same thing for the castles S. So rather than just going through to the north and leaving the model, we need it to also be able to move through not just the north but also the east. That is going from the north. Let's go back to this. So when we have movement from the south, here is the south, the movement from the south to the north, yes, we already established that we also need vehicles to be able to move from the south to the east road. So that is, and in order to do that, like we also did in with the road, the east road, we need to be able to introduce the select output so it can be able to move beyond just one place at a time. So when we introduce that into the model, into the flow chart, we can introduce it into the flow chart. So this means that it will be able to connect to more than one. So and in order to achieve this, so we can also edit. So we have the south. So the source is from the south. Where do we want the south to connect to? We need it to connect to both the north and the east. So that is NE. So we can change the properties. So we can still leave this as a 0.5, that is 50%. So we need it to connect to NE. So so at this point in the movement here will connect to the node, though we have not created the connector for this, because when we look at everything we've done here, we've only been able to create the source for the road east. We've been able to create a source, but we don't have a movement along it. So that means we still need to be able to create whereby vehicles coming from every other source will be able to pass through, move like they can move to. We have the movement from here, then car can move to. That is true it, but we don't have it yet for the car source E, which is the road east, in which we're still going to create. But the first thing we have to do here is, okay, let's just create a connectivity whereby we know that when we have the road south, it can connect to the north and the east. We've done that. When we're also for the source here for the north, it should be able to connect to the north, should be able to connect north should be able to connect to the south and also the east. So the south and also the east. And in order to do that, we also need to create the so we also create a select output so that we can be able to link it to two of the places at a time. So the properties, we can change this to, so from the north it will be to the south and the east. So now we can see, so we have been able to create for this, for the northeast. So that is the movement within the east, we go through the north and the south. The movement from the south will go through the north and the east, and the movement from the north will go through the south and the east. So, but we have the move through car moving to the north, and we have that also for the south, but we don't have for the east. So that means we need to be able to create can move to, so that even when we have the movement from these other sources, it can also from the north, from the south, it can be able to move through the east. So we need to be able to create that. So that means we'll go back to the road traffic library. Then we have the can move. So we've been able to drag it in. So as it is now, you can just rename this. So we have this is can move to the north, can move to the south. Then we should be able to have this as can move to the east. So then for the road, we're able to change the road to the east road. So we have this then. So this is it. So for this now, it's quite easier for us to connect this also to the car dispose. So we know that when any of them is moving through the east, then it can also leave the model. So we've been able to do that. So now that we have been able to do that, we now see from the source here, the source from the south is leading to the north. We have that already sorted out, which can also move to the car dispose. But now it's item for us to be able to connect the vehicles or the cars moving from the south, not only going to the north alone, but some of them also going through the east. So that means we use the connector here. We have this, then we connect it that way. So that means the car source from the south going through to the north, and some of them are also going through the east and also going through the car dispose. We also do the same thing for those coming from the north. We know we want it to go to the south and the east, so we have it already moving to the south, but we also need to be able to create that moving from the south. We have it moving to the east this way. So this is it. So from here now, we will be able to, when we go back in here, we'll be able to have vehicles leaving the south, some of them going to the northern part of the road, north side of the road, and some of them also to the east side of the road. And we also have those coming from the north going to the south and also going to the east side of the road. Then the same thing also for the ones coming from the east. We have them going to the north and also to the south. So this is it. So for the source coming from the east, we have it going through the north. We've already been able to do that. The north, this is the north, going to the north and also going to the south. Then for the ones coming from the south, we have it going to the north, yes, and also to the east. And the ones from the north going to the south and also going to the east. Everything all leading to out of the model this way. So the other thing that we need to be able to look out here for is when we are moving from the east is moving in a forward lane. This is when we go into the properties of that of the east. Just trying to make a point here. When we look into the properties of the east, so that means the vehicles are moving in a forward lane, leaving the east forward lane to other parts of the road that is forward lane. But when we have vehicles coming from the north and coming from the east, so they are coming in not through the forward lane but through the backward lane. This is the point. When we have vehicles coming from the north here, when we have them coming from the east, they are coming here in form of a forward lane. This is the source, so it's a forward lane. But when we have it coming from the north or coming from the south, coming in, they are coming, we can see it is through the backward lane. They're coming into the backward lane and also this backward lane. So the point I'm trying to make here is under the car move to east, knowing fully well that we have them coming from the south and also coming from the north to the So we need to edit and check for this here, the properties. So we have to make sure it is end of backward lane. So it will not be the forward lane, but rather it will be the end of the backward lane because they are coming into the backward lane, not out of it. The source is the forward, but when it's leaving, then that will be the backward lane. So we will have this change to this, and here we have it. So we can decide to run the model. So we can see the movement. And to quickly put this in a window 3D, in a 3D animation. So we can see it leaving the source from. So the next phase we're going to be looking into now is the introduction of the parking lot. And this is our layout again. So we want to try as much as possible to introduce the parking lot in the east road. And in order for us to do that, we're looking at setting up a parking lot around here. So that means vehicles or cars coming from whether the north or the south coming into here. Maybe probably let's just say for example there is a supermarket, there is a mall around this place. Then when they come in through this place, there could be a place where they can park. We know that all things being equal, because this might be too close to the point of intersection and it might cause traffic congestion around there. But just looking at it, all things being equal here, that we want to set up a parking lot around this place. For the first thing before we can do that is that we need to be able to increase the intersection point here. It is a little bit, it's not so wide. We could say the point here, it's not so wide, so it's a bit small for the movement of vehicles because the congestion, the intersection point is a little bit narrow, so we need to widen it up a little bit. And in order for us to have a good look at what we're doing here, so we can decide to just increase we can decide to increase this to maybe, let's just say, 125%. We need to zoom it in a bit so we can see that we have a little bit much more space. So what we want to do is that the road we drill in the beginning in the part one, we need to be able to move it back a bit so that the intersection area can be a bit expanded. So, and in order to do that, in the process of doing it, if we don't drag it carefully, that might lead to the end of the road, in sense of it might cause a road blockage. So what we need to do is that in the process of dragging, we'll still keep checking if it is all still connected. At any point when we drag and we notice that it is not connected, we need to undo and still make sure it is connected. What I'm trying to say is this: when I click on the road east, or the eastern road, and I try to drag it back a little, let's say this, you can see it has disconnected from the main road. So you can see the disconnection is also, you can just undo that, see it's back, it's connected again. So that means in the process of trying to drag, we need to do it gently and make sure that there is still connection. See, I dragged it back a bit, but there is still connection within the road. If I try to do that again, there is still connection between the road. So we have to make sure that whatever thing we're doing here, there is still a connection at the end of the day. You can see you have that. So you can still decide. Let me see if I can still drag it a bit more. So dragging it a bit like that, there is still connection. So we do it for all the parts of the road so that we can have. So you can see it's becoming a bit wider compared to how it was in the beginning. So we do the same also. Disconnected is disjoint. So it just have to take it back a little bit and I mean try to okay, it's still connected. So it's becoming wider, but let's see. Can we still move it back a bit more? We can still move it. So just dragging it bit by bit. So you still have something like this. So you can see we have much more space being created compared to what we had at the beginning. So if I still want to be a little bit much more, let's say I want to see okay the possibility of moving it a bit back. You can see I can still have that. Can I still move it more? Okay, you can still have that. So you can see it creates more space for us. Can I still be much? Can I still try to do it? Okay, yes, you can still do that. So it's wider now, whereby it helps to accommodate the movement of vehicles around there. So can I do also the same thing here? Okay, so let's just stop here. So we can see it's wider. So movement around the intersection is way easier now compared to what we had in the beginning where they're all close to each other. So there is enough space for movement of vehicles or movement of cars at this point of intersection. So after this, we can decide to try to run the model. Now, the reason why at every given point when we had anything or when we modify the chart flow, we try to run the model is just to see what the changes, whatever changes we've been able to make, if it is reflecting in the model when we run the model, or probably we are getting the desired output at the end of the day. So at every point when we tend to do that, we are using that as a means to know that okay, yes, this is done well. And I also said it at the beginning part of the video, or in even in the previous video, that at any point when we have an adjustment or a modification in the chart flow and we try to run the model and the model is not working or is not functioning well, that means there is a problem somewhere in the process of doing that. So that means we need to look out for something, or we need to correct something, or we need to change something, or probably fix the error. So for the case we have here now, so since we've been able to expand the road a bit, let's see how it will react. Let's see the reaction of that when we run the model. So we can be able to tell and see the difference between what we've been having before now and the end product of it now. So looking at this now, we can see it is a bit more spacious compared to what we had before. There is a little bit of space compared to what we had before at the point of the intersection. So cars can move freely. So the the chances of having any form of congestion among cars, or probably any form of collision among cars, will be less likely at this point because we've been able to create more space at that point of intersection here, as we can see from the simulation. So I'm just trying to adjust this. So you can see the cars moving and this one's going in this direction. So we have enough space for that movement now. We have enough space. So that is it. So let's get to the chart flow. So this is what we have in the chart flow. Let me try to turn this back to 100. So this is what we have in the chart flow, and we need to be able to create the sorry, I mean so we need to be able to add the parking lot. And in order to add the parking lot, we can see here, this is the parking lot. So we have to the parking lot to the desired area we want it to be. If I want it here, we want it here, anywhere else. But since from the image layout we are using, there is something of a parking lot here, so it is much more advisable we can just place it there. So we drag the parking lot to that position. So we can see it has been dragged there. So it now depends on, we can go under the views, then we go under the properties, then edit. We have the parking lot here. So instead of having it parallel on the straight line like we have, it's better we can put it on perpendicular. So when we do that, we will see that it is. So you can see we have it in a perpendicular form here, fitting into this area. And if we also want to make other changes to the parking lot, maybe we want to increase the centimeters, we want to, like we have here the number of parking spaces, we have 5. If we want to increase the number of parking spaces or we want to reduce it, we can do that here. And the length of the parking space also, if this is based on 6 meters, if you also want to increase or reduce, it can also be done here. So for example, if I decide to reduce the number of parking space to 3 here, so we will see that the number will also reduce. You can see we only have 3, but let's keep it at 5. Keep it at 5. So now we've been able to introduce the parking lot in the East Road into the layout. So now that we've been able to do that, so the next thing we are going to do is that we can have vehicles, or we can have cars coming from the north, we can have cars coming from the road east. We can have them coming from those two directions to the road east, and try to make use of the parking. For the sake of this video, we are only going to be looking into cars coming from though we can also do that of the south, but so that it will not make it too complex to understand. We can always try that afterwards on, probably you can do that on your own, but let's just try to take the only taking into consideration the cars coming from the north. Let's assume that it is just only the cars coming from the north that will be making use of the parking lot. So that means pass through the East Road can make use of this parking lot. And in order to be able to achieve that, let's have them and also the ones going to the East Road. So now, taking a look at the select output we have to the East Road means that there is no stopping at this point. So the cars coming from the north will move, going through the east to the end of the model. That means that there is no stopping point. So that means we need to be able to we need to be able to create a stopping point where they can park. So rather than this continuous movement to the north, so that means we have to delete this connector that leads it to the car move to the east, that leads out of the model. So that means we don't have that. We don't want to have that continuous movement. We want to be able to have the movement from the north that's leading to the east, yes, but there is going to be a point of the select output also that will lead to the parking lot. And in order to do that, that means we have to delete this connector, like I said. This first one, we can delete this connector. So we've been able to delete this connector, and that means that we need to be able to create a new connector that can also lead to the parking lot. So why are we making use of this, the select output here? We are making use of the select output to show that there are two movements. So not every vehicle that are coming from the north will be using the parking lot. So let's just say out of the 1%, the probability, let's just say only 0.1% will be making use of the parking lot. So that means that there are some other vehicles that will still go their way, that is continue the movement without necessarily stopping at the parking lot. So that is more of the reasons why we need to be able to create a select output in order to accommodate and show that only 0.1% will be making use of the parking lot, or if you want to say 0.05, whatever probability, sorry, whatever probability we are going to be making use of in that case. So without wasting much time, let's just have our the select output. Let's drag it here. So we have it here. So that means now we can have two forms of connectors. That is one connector showing that the car moving from the north through this the southeast. We know the southeast, the one for the south will continue, but the one for the east that we're dealing with now. So we have two connectors connected to it. So one will continue moving through the east, and the other will be for the parking lot. So you can have it this way. Then that means we have the movement again, which continues. So that means for the actual vehicles that are moving, that are not using the parking lot, they can continue this way in this direction. But since this, so let's rename this, because the reason why we're having this is because of the parking lot. So and if we also want to decide to actually look at it from this view, so you can say we have the select parking, we have the probability. So when we want to change this, I think we'll still come back to these afterwards. So we can decide to change the probability rather than the 0.5. We can change it so in order to know the number that will be moving in this direction downward here, or probably the one coming down. So now that we've been able to do that, we also need to be able to create another one which shows the double movement. Sorry. So as it stands now, we have two movements from the vehicles that are coming, or the cars coming from the north. So that is at this point of the parking now. So one will be for parking, and the second one will continue their movement to the east, through the east road to the car dispose. And if we're using this first one leading us into the parking lot, so that means this, since we already have this point as the select parking. So that means at this point it will be moved to. So we need to be able to create a movement here, which will be our move to. So that is, it is moving to where? Where is it moving to? That is, it is moving to the parking lot, because we need to be able to explain that why the second connector will lead to the move to the east, so that is, they continue their movement along that road. And so, like we said about editing this, we can just change the properties. So since we have the first one moving in that direction, so we can just let it be 0.1%. 0.1 probability is 0.1. That is 10% of the vehicles moving on that road. So we already have that. So then now this is, since this place is for the parking lot, so that means they are moving to where? Where are they moving to? So we go to, so we should be able to introduce the move to, car move to. So the cars, where are they moving? So we have move to where? We can just put move to parking. So that means they're moving to parking. Then, so the next thing we need to do is also to edit the properties here. So since we know that we have the parking, the select parking, move to parking here. So that means the movement here, we have to go under the properties. Now, it's not moving to the road. So that means the movement there using the move to is moving to the parking lot. So not just the road, but the parking lot. So we need to specify. It's the parking lot. So now, which of the parking lots is it moving to? The one we had selected initially. So we pick that up, and this is done. Then, so the next thing we're also going to do this, we know there's going to be a movement along the parking lots, which we already created. So we need to also be able to look into the delay time. So that is when the vehicles moves into the parking lot. So what is the delay time? What is it like? So we need to be able to have a minimum delay time, an average delay time, and a maximum delay time, or yes, the delay time at the parking lot. So in order to do that, we go under the process modeling library, then we look for delay. Sorry, now this is delay. Then you can drag it. So we can drag it in delay. So with this, we can edit under the delay. So at that point of the delay, that means the vehicle or the car is parking there. So we can just call it parking because as at that time it is parking. So there is a delay in sense of parking. So we can see here the triangular talking about the minimum, the average, and the maximum. So for this, we can, since we're working based on seconds, we can have it as 15 seconds minimum. We have let's say 30 seconds average, then maybe 45 seconds maximum. But if we decide to keep it as 15, 30, and 45, we have here is the seconds. But is it possible for any vehicle going into the parking lot to stay there for maybe 15 seconds, 30 seconds, or 45 seconds maximum? It is not realistic enough. So probably we can just keep this as minutes. Maybe they're trying to use the restaurant there, or probably using the restroom, anything at that particular parking lot, or probably there is a meeting going on. So let's just say minimum of 15 minutes, um, an average of 30 minutes, and maximum of 45 minutes. So, and the capacity, we know the capacity of the parking lot we have that we created, we have it as 5. So rather than having one there, you can have it as 5. So we don't have any agent location. So with this being said, we can decide to run the model. So we can decide to run this model and see how it reacts in the network, in the road network. So we can see through the course of it, we can see the vehicles coming from the north using the parking lot. You can see one vehicle there. So I'm trying to speed up so that we can. So so we can see some of the vehicles coming in because we still have a lot of vehicles coming in. So we only have one at the parking lot at the moment. But if we are to move this quickly, we'll see a whole lot of vehicles coming into the parking lot. So we can see we already have 2, and it might continue that way. But in this case, what if in the process of having this, we already have 5 vehicles or 5 cars in the parking lot? So what now happens to the vehicles coming that also wants to use the parking lot? Now we already we have three. If I continue with it this way and it completes five, then we'll get an error message. Vehicles there, but we still have more vehicles trying to come into the parking lot, but there is no space for them for to accommodate message. That is because we did not regulate or we did not add it into our flow that at any point where there is a maximum number of cars in the parking lot, then other cars that will also wants to that would also continue on the east road. Now we have four. I think if we have to wait a few seconds more, we would have about five vehicles or five cars in the parking lot. Then maybe probably by the time the sixth vehicle to get the error message. So it shows that we still need to go back to flow charts, then edit to show that okay, when we have the maximum number, then the other vehicles should continue on the road, on the east road, without necessarily maybe causing any form of traffic congestion around that road. Because in reality, when the parking lot is filled up, you don't see cars waiting on the road because they have to use it. They have to continue on the road, maybe probably look for another parking lot in on that road, or probably in the maybe on other parts of the road, rather than waiting on the road and expecting that any of the cars that are at the parking lot would leave in order for them in order to accommodate them. So like I said, but because I don't want us to spend too much time waiting on the model to have the five complete cars and expecting the sixth one, how are we going to be able to fix that in the case where we know that the the parking lot is already at the maximum point, but we still need other vehicles that wants to come in. If they can't, they should be able to continue on the road without necessarily showing a error message. Let us look into that now. So here we have it. We're back to this. So we already created. So that means the vehicles are moving to the point of the parking here. So when it's already at the point of maximum, rather than them waiting or causing an error in the model, the only thing we need to do, the connector we have below at the move to, we click on it, then we direct it into this, connect it up, then we have this. So that means when there is a maximum number of cars parked here, so rather than the vehicles who are meant to move, since we already what we had it with the instruction we've given to it is for it to be at the point of the parking, and the moment this there is a maximum number like we've already stated here. So rather than they just waiting there, so the excess ones that there's no place for them to park, or the drivers who won't have any opportunity to park, they can always continue on that road leading to the car move to the east, and they continue then exit through the car dispose. So that is the point we're trying to make. So but if we did not create this, that means that if we have about 10 cars that are meant to be here, and within the time they're waiting, maybe when we have a maximum of five and the sixth car is coming in and there is no space, there will be an error message because that particular car will be blocking the road, because there is no way in entry into the parking lot. And when that is impossible, then that is when we get the error message. But rather than that happening, the moment we have a maximum and we have vehicles that ought to go in, but they were unable to do that, then the next thing they will do is to continue on the east road and probably look for another parking lot in the on that road. So that is the reason why we have to create this. Now the next phase we are going to be looking into now is the addition of the bus and the bus station. Thus far we have been able to work on this basically on the use of a vehicle or a car. But right now we want to see how well we can introduce a bus into the layout and also the flow chart in a way whereby we can also have a bus station added to show how the bus stops at the designated bus station, then continues to move within the layout. So from this, we are going to be having the addition done in the like what we have here. It's going to be done in the south. So we have it from the south to the north. So just for the sake of this, we'll have the addition done from the south to the north. So that means and along the line, along the road from this south leading to the north, we can have a bus station somewhere around where we can set that up, and we'll see how it interacts. So the first thing we have to do is we have to create a new source at least in order to be able to introduce the bus. So that means we have the car source, we introduce it into this. So now that we have the car source, we can decide to, so now we know that the movement of this car source will be from the south, like I said, maybe to the north. So that means the movement can be from south to the north. But if we want to create it in a way whereby it has to go through the south and also the east, then that is when we get to bring in the select output in order to show that it will go into different directions. But for the sake of this now, we would wholly limit it to the movement to the north. But like I said, if we also want to extend it to the east, it can be we have the select output connecting to the north and also connecting to the east. So I think that is quite explainable. Or so the first thing is, let's connect this using our connector. So we have it connected, so we need to edit the properties here. So rather than we having it as car source, we can change it to bus source. So we have it changed to bus source, and the arrival rate, we have 1000 per hour. That is when we're making use of the car. But since it's bus, it's not really something that we get to have often on the road. So let's just reduce this to 50. And yes, we have it on the road. So what road are we looking into? The road is going to be from the south. So let's have it from the south. So we already have it from the south. So the next thing is the car. Because now we want to make use of a bus, so that what we need to do is to create a custom type. In creating the custom type, we can change it to bus because that is what we want. Then we have the next. We click on next. Then here we have the bus, so we can pick from any of the bus. Let's just pick bus one. Then we have the next. Then afterwards, so then we finish. So we wait for that to reflect under the new car. Just give it a few seconds. So also under the properties under the car here, we have the length, which is 5. For this, we can change the length to 10, and also the initial speed. We know the speed of a car is not the same as that of a bus, so we can change also the initial speed to maybe 40, 38, 35, 45. So we'll change the initial speed at that point. So now, now that we have the bus here, we can go back to the main page. We go back to the main page, we click on the bus again, still visit the properties. So we can have it here. We have the bus. So for the length, let's keep the length as 10. And like I said earlier, the initial speed. The initial speed, we can keep it at 40. So then every other thing. So since it's moving from the south to the north, so it will still be a forward lane. It will still be a forward lane. So we have this then. So we have that sorted. So that means we've been able to add the bus source into the flow chart. So when we run the simulation, we'll see the introduction of the bus the into the model. So I think let me just quickly do that within in the coming into the model, you can see. So the reason why we only see it once in a while is because we have more cars in the model than the number of bus we have. So, but the major thing is that we've been able to introduce the bus into the model. So be able to create. So what we need to do is to create a bus station or a bus stop, so we can have a bus stop. So when we have vehicles coming in this way, we can have a bus stop around here to accommodate the the bus. Maybe in case maybe we have passengers here, we can see the bus coming in this. This is the bus, so we can have passengers come into into the bus or hop into the bus at this point. So we will try to do that now. Let us introduce the bus stop into the model. So here in the layout, we can decide to bring in the bus stop like this. So been able to introduce the bus stop. So if we want to enlarge it a bit, we can do this just to stretch it. But if you want to reduce or we want to expand, we can just drag it by this point to expand. So now we have the bus station. Then we can go under the properties. Then we can edit. Oh, we have it already here. So we already have it the bus stop here. So that is sorted. So now that means that when we have our bus coming from the south to the north, then there is a need for them to stop here. So that is where we go back to our flow chart and we introduce our move to. So we introduce our move to into the flow chart. So that means in the course of this movement here, we have, so rather than using car, we have bus move to, where is it moving to? It's moving to stop. So we have bus moving to stop. And like we said, when it gets to this point, okay, let's edit the properties here first. So now the movement from the south road, is it through the road? That's something about the parking lots, but this time around we have it as in form of bus stop. So that means there is a stop there. So then we pick on this. So that means it is at the designated stop we'll have for it. So after introducing that, we also need to be able to look into our delay time. So because when it gets to that stop, what happens? So we need to be able to regulate our delay time, and that means we'll go under the process modeling and we have the delay. So we can introduce the delay. Okay. So we have been able to introduce the delay into it. So looking at the duration of how long it is going to take before it moves along. So for the delay period within that time, so if we are to edit the properties here, so rather than using delay, we can just use, as at that period the bus is stopping. So let's just call it stop. I will have said bus stop, but because we already have bus stop initially used, so then we can look into what is the delay time going to be like. So how long does it take? Sometimes we can say within 10 seconds, 15 seconds on average, then 30 seconds maximum. So this time around, we'll keep it as seconds because this is a bus station. You can't spend a lot of time at the bus station or at the bus stop. So let's just keep it within a minimum of 10 minutes and a minimum of 10 seconds and a maximum of 30 seconds. So we have just the capacity is just one, so we can't do anything about that. So we have it this way. So afterwards, we can close this. So that means we let our bus stop here, whereby when we run the model, the buses are coming. We'll have to stay here to pick up passengers before they continue on that road. So we've been able to introduce that. So with this, we can now decide to run the model. So we have to wait for a few seconds so we can have the bus stop at the bus stop. Then we can continue with the last phase of this model, and that is the addition of the traffic light. So but let's just wait to see if when we have our bus from the south coming to the north, if it stops at this bus stop. So the reason why we might not have an error like the way we did when we were trying to set up the parking lot, when we have a maximum of five, as at that point in this case, okay, I think we have the bus coming now. We have the bus coming. The reason why we might not have the error in this case is that there is a duration between when the bus comes. So within the time the next bus might come, the current bus might have left the the bus stop. So so we can see the bus trying to enter the bus stop. You can see it's already in the bus stop. Then maybe waiting for a few seconds, then it moves out again. Maybe after picking the passengers. So so that is it. Then we proceed to the final part, which is the addition of the traffic lights. So the last part of it, like I said, we have to introduce the traffic light. So here we have it, still under the road traffic library. We You can just drag it into any part of the chat flow. Mm. So we have it here. So since we have it, we can edit the properties. We go under the properties. So yes, traffic light, we leave it that way. But under the intersection here, so where do we want it active? We want it active under the intersection. Now, at this point now, we want to know how do we regulate it since we're just using, for this, we're just using the red and the green. So coming to the, let me draw this back a little bit. So this is our intersection point. So this is line one. We can see this is the line one. So for the line one is the movement from the south, whether to the north or to the east. So when this is green, that means this other one, what line is this? So this particular one can stay as red. Then the line two, this is the line two, can also stay as green. And for this, we can decide to increase maybe the number of seconds since we tend to have a lot of movement around there. So we can increase this to 25, and this we can reduce this to 20 seconds. So now, so that means at this first point, when the vehicles coming from the south and the ones coming from the north, when it is showing green, so that means the vehicles on this side, the traffic light here will be showing red, which means that there can be vehicles coming in from the east. So this can be green. So that means at that point this will be red. So, but if we also, so after that, after the 25 seconds, then it moves to the second phase, and that is at, so that means at that point, this will be red. That means this will be green. So this will be the only one that is green. So there will be movement to the north, and there will be movement to the south at this point. So we have this setup already, showing the introduction of the traffic lights. So so with that we have the traffic setup. So we can also say after when we've been able to set up the traffic light, we didn't include that of the yellow, but that we can also do if we really want to do that. But I won't be including it in this, but I will just explain how we can be able to introduce the yellow traffic light. So you can see at this point, when we come to this point, you can add yellow face. So we can use this to add a yellow face into the faces. But like I said, we won't be doing that since it's just a simple T intersection. So now the next thing is for us to be able to add the density map. And in order to add the density map to show the movement within, sorry, not for us to add the density map, we have the road network descriptor here. So we can click on it and drag it into the flow chart. You can just drop it at any point in the flow chart. Then we click on it, then edit the properties. So the road network, so that means the particular one we created. So we click on that. So we're choosing the road network. Then also enable density map. You have to enable this here. So we already enabled the density map. If we want to the green speed level, maybe this is the red speed level, so you can see all that, but we won't be making any changes to that since we already have this sorted. We close, then finally we can run the model. So we have this green just because of the density map we added. So so you can see as soon as there were movements, start changing, telling us based on the speed level. Light is already effective. At this point, you can see when, so that is it. So far through the course of this tutorial video on the road traffic intersection, with the first thing we had to do was to draw the results to the addition of the 3D animation. Then after that we had to draw an intersection, which is the phase 3. Then after drawing then we have to model a parking lot. Then after modeling the parking lot, we also model the bus and the addition of the bus station. Then the fifth stage, the sixth stage is the addition of the traffic lights. So that is it. We'll see if we can still take maybe one or two more tutorials on the road traffic setup using a different layout, but I'll still see if we can be able to do that. But if not, then we'll be able to try something different. So but whichever way it is, I'll see you in the next video. Thank you.